The National Fire Protection Association, or NFPA, has not explicitly defined the terms exposure to physical damage or exposure to severe physical damage. However, the NFPA offers guidance for determining when something is considered exposed to physical damage. According to the NFPA, exposure to physical damage occurs when an item is likely to be damaged by physical forces. These forces can include impact, vibration, or crushing. Specific examples of exposure to physical damage include, firstly, falling objects, secondly, moving equipment, thirdly, vehicles, fourthly, vandalism, fifthly, fire, and sixthly, natural disasters. On the other hand, exposure to severe physical damage refers to situations where an item is likely to be severely damaged or even destroyed by physical forces. Examples of exposure to severe physical damage encompass, firstly, explosions, secondly, earthquakes, thirdly, hurricanes, fourthly, tornadoes, and fifthly, floods. Generally, exposure to severe physical damage is more probable when an item is located in an area with a higher risk of natural disasters or other catastrophic events. It's crucial to recognize that determining whether something is exposed to physical damage or severe physical damage often involves a degree of subjectivity. There isn't a rigid definition, and the decision must be made on a case-by-case basis, considering the specific circumstances and potential hazards. If there is uncertainty about the classification of exposure, it is recommended to consult with a qualified electrician who can assess the situation and provide expert judgment. The distinction between physical damage and severe physical damage is not always clear-cut, requiring careful evaluation of the potential risks and the severity of the potential damage. It hinges on the likelihood and extent of damage from physical forces. To further clarify the concepts, let's delve deeper into the factors that contribute to each type of exposure. For physical damage, the focus is on the potential for damage that may impair the functionality or reduce the lifespan of equipment or structures. This could involve minor impacts, vibrations from nearby machinery, or exposure to environmental conditions that gradually degrade materials. For instance, electrical wiring running along a wall in a factory might be considered exposed to physical damage due to the risk of being bumped by forklifts or other moving equipment. Similarly, equipment located in an area prone to vandalism could also be classified as exposed to physical damage. The key consideration is the likelihood of damage occurring under normal operating conditions or foreseeable events. In contrast, severe physical damage implies a much greater risk of catastrophic failure or destruction. This involves exposure to forces that could cause significant structural damage, render equipment inoperable, or even pose a safety hazard. Examples include the potential for explosions, earthquakes, hurricanes, tornadoes, or floods. In these scenarios, the forces involved are of a much higher magnitude, and the consequences of damage are far more severe. For example, an electrical substation located in an area prone to earthquakes would be considered exposed to severe physical damage due to the potential for ground shaking to damage equipment and disrupt power supply. Likewise, a building located in a floodplain would be considered exposed to severe physical damage due to the risk of flooding. The determination of whether something is exposed to physical damage or severe physical damage also depends on the specific characteristics of the equipment or structure in question. Some equipment is designed to withstand a certain level of physical stress or environmental exposure, while others are more vulnerable. For example, electrical enclosures designed to be weatherproof are better protected against damage from rain and moisture than standard enclosures. Similarly, structures built to withstand earthquakes are less likely to suffer severe damage than structures that are not designed to withstand seismic forces. The NFPA codes and standards provide guidance on the appropriate installation and protection methods for electrical equipment and structures in various environments. These codes and standards are based on best practices and industry experience, and they are designed to minimize the risk of physical damage and severe physical damage. For example, the National Electrical Code, or NEC, specifies requirements for the installation of electrical wiring and equipment in hazardous locations, such as areas where flammable liquids or gases are present. These requirements are intended to prevent explosions and fires that could result in severe physical damage. In addition to the NFPA codes and standards, local building codes and regulations may also apply. These codes and regulations may specify additional requirements for the protection of electrical equipment and structures in specific geographic areas or environments. It is important to be aware of all applicable codes and regulations when designing and installing electrical systems. When assessing the risk of physical damage or severe physical damage, it is important to consider the probability of an event occurring and the potential consequences of that event. Probability refers to the likelihood that an event will occur within a given time frame. Consequences refer to the potential damage, injury, or loss that could result from an event. Risk is a function of both probability and consequences. For example, the risk of an earthquake in an area with a high seismic hazard is greater than the risk of an earthquake in an area with a low seismic hazard. Similarly, the risk of a fire in a building with flammable materials is greater than the risk of a fire in a building with non-flammable materials. When assessing risk, it is important to consider all potential hazards and their potential consequences. This may involve conducting site assessments, reviewing historical data, and consulting with experts. Once the risks have been identified and assessed, appropriate mitigation measures can be implemented to reduce the likelihood or severity of damage. Mitigation measures may include structural improvements, equipment upgrades, or changes to operating procedures. For example, a building located in a floodplain could be elevated to reduce the risk of flooding. Similarly, electrical equipment could be protected by installing surge suppressors or grounding systems. It is important to select mitigation measures that are appropriate for the specific risks and the specific environment. The effectiveness of mitigation measures should be regularly monitored and evaluated to ensure that they are providing adequate protection. In some cases, it may be necessary to implement multiple mitigation measures to address a single risk. For example, a building located in an area prone to both earthquakes and hurricanes may require structural improvements to withstand seismic forces and wind loads. In addition to physical protection measures, it is also important to have emergency preparedness plans in place. These plans should outline the steps to be taken in the event of a physical damage or severe physical damage event. Emergency preparedness plans should include procedures for evacuation, communication, and damage assessment. Emergency preparedness plans should be regularly reviewed and updated to ensure that they are effective and relevant. Training should be provided to all personnel on the emergency preparedness plans. The determination of whether something is exposed to physical damage or severe physical damage is a complex process that requires careful consideration of various factors. There is no single definition that applies to all situations, and the decision must be made on a case-by-case basis. It is important to consult with qualified professionals to ensure that the risks are properly assessed and that appropriate mitigation measures are implemented. Understanding the potential hazards and taking steps to mitigate those hazards can help to protect people, property, and the environment. The NEC, published by the NFPA, contains requirements intended to minimize the risk of electrical hazards. These requirements address the installation and use of electrical equipment and wiring. The NEC is updated every 3 years to reflect changes in technology and industry best practices. State and local jurisdictions adopt and enforce the NEC, often with amendments to address local conditions. Compliance with the NEC is essential for ensuring electrical safety. Article 100 of the NEC provides definitions of terms used throughout the code. While it does not specifically define exposure to physical damage or exposure to severe physical damage, it does define other terms that are relevant to this discussion. For example, it defines location damp as a location that is subject to moderate degrees of moisture. It defines location dry as a location not normally subject to dampness or wetness. A location classified as damp might require different types of electrical enclosures than a location classified as dry, due to the increased risk of corrosion or other damage. The NEC also contains requirements for the protection of electrical equipment from physical damage. These requirements vary depending on the type of equipment and the location where it is installed. For example, conductors installed in exposed locations must be protected by conduit or other approved means. The NEC also requires that electrical equipment be installed in a neat and workmanlike manner. This means that the equipment must be installed in a way that is safe and efficient, and that it must be properly supported and secured. The NEC provides specific requirements for grounding and bonding electrical systems. Grounding and bonding are essential for preventing electrical shock hazards and for providing a path for fault current to flow back to the source. The NEC also contains requirements for overcurrent protection, which is designed to protect electrical equipment from damage due to overloads or short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current before it can cause damage. The NEC also includes requirements for wiring methods. Wiring methods specify the types of conductors, cables, and raceways that are permitted for use in different applications. The NEC also addresses the installation of electrical equipment in hazardous locations. Hazardous locations are areas where flammable liquids, gases, or dust are present. The NEC provides specific requirements for the design and installation of electrical systems in hazardous locations to minimize the risk of explosions and fires. The NEC also includes requirements for special equipment, such as swimming pools, spas, and electric signs. These requirements are intended to address the unique hazards associated with these types of equipment. In addition to the NEC, other codes and standards may also be relevant to the determination of whether something is exposed to physical damage or severe physical damage. For example, the International Building Code, or IC, contains requirements for the structural design of buildings, including requirements for resistance to wind, snow, and earthquakes. The IBC may also contain requirements for fire protection systems, such as sprinkler systems and fire alarms. The International Fire Code, or IFC, contains requirements for fire prevention and fire safety. The IFC addresses topics such as fire hazards, fire protection systems, and emergency preparedness. These codes and standards work together to provide a comprehensive framework for ensuring the safety of buildings and electrical systems. When determining whether something is exposed to physical damage or severe physical damage, it is important to consider all applicable codes and standards. It is also important to consult with qualified professionals who have expertise in electrical safety and building construction. The specific requirements for electrical installations can vary depending on the local jurisdiction. It is essential to consult with local authorities to ensure compliance with all applicable codes and regulations. The interpretation and enforcement of electrical codes are often left to the discretion of local inspectors. These inspectors have the authority to interpret the code and to require modifications to electrical installations to ensure compliance. It is important to work closely with local inspectors to ensure that electrical installations are safe and compliant. Continuing education is essential for electrical professionals to stay up to date on the latest codes, standards, and technologies. Many organizations offer training and certification programs for electricians and electrical engineers. These programs can help electrical professionals to maintain their skills and knowledge and to provide the highest level of service to their clients. The determination of whether something is exposed to physical damage or severe physical damage is a critical aspect of electrical safety. By understanding the potential hazards and taking steps to mitigate those hazards, it is possible to protect people, property, and the environment from electrical hazards. It is always recommended to consult with a qualified electrician for specific advice on electrical installations and safety. A qualified electrician has the knowledge and experience to assess the risks and to recommend appropriate mitigation measures. The electrician can also help to ensure that electrical installations comply with all applicable codes and regulations.